Okay, let's turn our attention to the catalysis and how fast it happens. Topic known as kinetics. And before we look at the properties of enzyme kinetics, let's look at just the regular kinetics of a chemical reaction without an enzyme. Just some reactant, let's say you heat it up in a test tube with a Bunsen burner, it breaks down to give B. Okay, this is in solution. What's the rate? The rate would be the change in concentration of A per minute or per second, however you want to describe it. That's the rate of the reaction. We'll use the terms rate or velocity interchangeably. Just how fast are you losing A? And of course that should be equal to how fast B is being produced per minute. Same thing. And it turns out in an ordinary chemical reaction without a catalyst, how fast you make the product, the rate of product formation, depends on how much of the reactant you started with. And that's what you see here in these graphs. So you start with a certain concentration. This is the concentration of A versus time. Let's say you start with this much in solution. You see A going down. You're using up A. We're not seeing the production of B here. That would maybe be on a different graph. We're just seeing A going away because we're converting it to B. So its concentration drops over time, and at the beginning it kind of looks like a straight line. But eventually, as the reaction approaches equilibrium, this slows down. But you notice this relationship here. The less A, the slower the rate. The rate is the slope of this line. The rate would tell you the change of A per minute. If you went back and did the same experiment with another test tube and put in only half as much, you'd see a rate of product formation, a rate of substrate disappearance, which is lower than that. Or if you did it another way with even more concentrated stuff to start with, you'd see a faster rate. The slope going is steep. And if you take these slopes, the initial rates, as they're called, initial because it's happening right at the beginning of the reaction before it reaches equilibrium. The initial rate, as a function of how concentrated it was to start with, you should see a linear relationship. The more of the stuff you put in the test tube, the faster you make product. It's like if you're popping popcorn in a microwave oven. You have a little tiny sample bag. After it starts heating up, at first you hear the pops, and you don't hear any pops, and then it hits a certain temperature, and it starts to pop, 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 and then it goes real fast, and then it slows down. Imagine if you put in a bigger bag, extra large size, the number of pops per second you hear during the production phase would be a lot faster. If you put it in 2 or 3 bags, it would get loud, right? The more you start with, the more you can produce per minute. A direct linear relationship. Okay, so